Well, hi guys, welcome back to Sego Codes. My name is Omolo. I want us to talk about three things today: cloud, infrastructure, and code. And then I will tell you what we get when we combine these two together. Now, cloud, we have Azure, we have AWS, and we have GCP or Google Cloud Platform. And then infrastructure, we can talk about things like virtual machines, storage accounts, and virtual networks in the cloud. And then code is basically some text that does something, like you code something, write something as a text, but this text kind of in a special way, it does something. This brings us to what we call infrastructure as code. Now, when we talk about infrastructure as code, the normal way that you currently use or that we use to maybe provision a resource on the cloud is usually by logging into the portal of the cloud provider, and then we search for that specific infrastructure, be it a VM, be it a storage account, or be it a vault, key vault. Okay, you have to log into the portal and then manually make several clicks to have the infrastructure provisioned for you. Now, this is something that can be very hectic, especially when you want to have several environments. Let's say you want to have test environment, staging environment, cloud environment, or you just want to get like a number of same environments that behave the same way and are actually hosting the same application. So here is where now what we call infrastructure as code comes in, where we now have the infrastructure and the code which we will deploy to the cloud to help us provision these resources. Now, what exactly is infrastructure as code? Infrastructure as code is the modern way of managing your cloud resources efficiently and easily. How does this happen? This happens this way: using code, which is just a text file that has a special syntax that is used to declare the resource that you want on the cloud. And then we have the infrastructure. Now, in your text file, or the code that you write, you define the resources that you need and their capacities or their specifications and how you want them to be deployed on the cloud. Now, why is it even easy to use IAC, or what we call infrastructure as code? Because with infrastructure as code, we use what we call a declarative approach. Now, a declarative approach is where, assuming you want to deploy, let's say, a virtual machine or even an app service, you don't tell the cloud the steps to follow to get the final product. Instead, you simply tell it the final product you want. For example, you tell it, I want my end state to have a virtual machine of 4 GB vCPUs, or just any capacity that you want. You tell it what you want, the final product, instead of telling it the process that it should go or undergo to get to that resource. Now, once you do this, because it is code, this can be versioned and you deploy it as, like, you can deploy it or even version it just like you can version your normal application codes. Now, this makes it easy for you to manage, for example, in a scenario where we have developers working on an application and then we have different environments. We have the test environment, we have the development environment, we have staging environment, and then we have production environment. Going the manual way of just going to the portal and making several clicks to get what you want, sometimes we can get what we call a configuration drift, where our test environment can slightly differ from our staging, which can also slightly differ with what we have in our production. And hence, the behavior of our application that we had in test environment that was working won't be consistent in our production environment, because we have got what we call configuration drift. But with IAC, or what we call infrastructure as code, we are sure that the replica or the same environment that we had in testing staging is what we're going to have in our production environment. Now, what are some of the IAC tools that we have, or infrastructure as code tools that we have? Now, the most popular tools that we have include the ARM templates, or what we call the Azure Resource Manager templates. Then we have Biceps, and then we have Terraforms, which all these tools achieve this. They do the same thing, but the approach can be kind of different, but they all aim to solve the same problem of using code to deploy resources on your cloud environment. Cloud environment can be Azure, can be Google, GCP, or even AWS, but the approach is same, simply using code to achieve what you want, the state of infrastructure in the cloud environment. Now, the question is, why do we need IAC? Number one, we need IAC to ensure that we achieve the same results or consistency. Usually, the manual way of provisioning resources or infrastructure can lead to what we call configuration drift, where one environment is different to another environment. But we want consistency so that what we test is what we get in the production environment. Number two, speed and efficiency. With IAC, we can have same environment as much as we want. For example, we can have 20 environments that are in the same state and hosting the same application. So compared to the manual way, you have to do these steps 20 times. But with the IAC, you simply write a code, and that code can help you get 20 environments that behave the same way. Number three is the versioning. Since that infrastructure is now defined as code, you can version it. In fact, if you want to like roll back, you can do it. And also it helps you track and collaboration. Since it is versioned, you can collaborate with other team members to help define the infrastructure that your team needs in the cloud. Number four, another reason why you need IAC is that IAC in itself acts as a documentation for your cloud environment, because just by writing down declaratively what you have in your cloud environment, this alone is a way of documenting your cloud infrastructure, because when another developer comes in, you don't need to tell them what you have in the cloud. You simply need to give them access to that code, and then they'll be able to see the exact image of what you have or how your cloud environment looks like. Now, in this series, we are going to focus on Azure Infrastructure as code, which means our cloud environment will be Azure. So we are going to look at the tools, that is ARM templates, the biceps and terraforms, and how they are used or how to configure them to help you deploy your infrastructure to the environment using code. We will focus mostly on ARM templates and biceps because they are Azure native. So through this, we are going to be able to define our infrastructure or define the end state that we want or the desired state that we want. Could it be a storage? Could it be a virtual machine or a key vault? And then we're going to use the Azure CLI, PowerShell, or even Terraform to help us deploy this to the cloud. And you're going to see all this in practice, how this comes up and how to ensure that you use your code, which you can version to have your infrastructure in the cloud. So that is it for this video, and I hope that this is an interesting topic that you won't want to miss. Writing code, and then this code can be versioned. You can collaborate on it, you can roll back, and use this code to deploy your resources on the cloud using CI/CD pipelines, using PowerShell, and using Azure CLI. So, come back to keep checking what I'll be releasing in the coming days, and also be sure to watch out for my events which I'll be hosting on the same Azure Infrastructure code, and we'll be cloud architects or cloud developers. So thank you all for watching this video till the end. My name is Osego, and see you all in the next video. Osego Codes signing out.